Hey everybody, my name is Johnny. I'm a water quality engineer with TapScore, and today I'm going to walk you through the most common mistakes you might make when collecting a drinking water sample for laboratory testing, and most importantly, how you can avoid those mistakes. So let's get started. One of the most common mistakes people make when you receive your water testing kit is you open it up and you see multiple bottles inside of the kit. You want to collect all of those bottles from the same source, from the same tap. The reason for this is that each of those sampling bottles tests for different contaminants. One might be for coliform, one might be for metals, one might be for VOCs. You want to collect all of those samples from the same location. Don't go running upstairs to the bathroom and collecting one of them from the bathroom and another one from downstairs and another from the children's room. You want all of these samples collected from one tap so that you get one comprehensive report of all the things tested at that location. When you're collecting your sample, you want to think about where you want that sample to represent in your home. If you collect a sample from your kitchen tap, it's going to represent the drinking water at your kitchen tap. If you collect it from outside at a spigot where a hose is connected, it's going to represent the water quality at the hose outside where that spigot is pulling water from. Different locations in the home or on the premises are going to tell you different things because there's different plumbing and there are other physical characteristics that are going to change the sample from point to point throughout the house. We always say one of the most common and smartest places to take a sample from is where you're consuming the most drinking water, which for most people is in the kitchen or at the kitchen tap. This one might seem obvious, but we still sometimes receive samples where people don't actually fill up all the sampling containers. You have to fill up every sampling container if you want to get a full comprehensive lab report back. Each container needs to be tested with some water inside of it. So, by all means, fill up the sampling containers. And perhaps step two, make sure you fill them up to the right height in the bottle. Some bottles you need to fill up all the way to the very tippy top. Other bottles you can fill up 3/4 of the way or 80% of the way. You will know based upon the instruction card in your sampling kit. So follow the instructions, always fill up every bottle, and make sure you're filling that sampling bottle to the appropriate height according to the instruction kit. If your drinking water testing kit includes analysis for VOCs, you'll probably have a slender glass vial in that testing kit. Samples for VOC testing, volatile testing, cannot have air bubbles in them when they are sent to the lab. For the simple reason that if there is an air bubble inside of that tube, then whatever contaminants that are volatile that are in the liquid below are going to evaporate into that gaseous state, into the air bubble itself. And you don't want that to happen. So if you're doing testing that includes testing for VOCs and you have one of these really slender glass vials, make sure there is no headspace. Make sure there's no air left in that vial before you cap it and send it back in. Now, this is a lesson you get taught when you're 4 or 5 years old, and for some reason, a lot of people forget when they're collecting their water quality sample. You push the water into the, you push the water, you pour the water into the bottle, and the bottle is filled or almost filled, depending on the instructions you're given. And then you go to screw on the cap, but you only partially screw it on. Well, I can't tell you how many times samples arrive at the laboratory and they have spilled because the cap was not turned enough. So tighten your caps, don't over tighten it and shatter the glass or the plastic. Don't under tighten it so that the water seeps out. Pay attention to tightening it just enough to make sure that your sample can transport safely to the laboratory without spilling. Just like collecting your sample from the right location can make all the difference in the world about the water quality report you get back, it also matters when you collect your water quality sample. If you collect a water quality sample first thing in the morning, you're going to get a greater impact from the metals and the potential leaching from the pipes. This is because the water has been sitting in contact with those pipes overnight. This is called first draw sampling. On the other extreme, you can let the water run for 5-10 minutes down the sink, down the drain, and then collect your sample. And at that point, you know your sample is coming from the source. It has not spent time sitting in the pipes overnight. You're getting kind of a fresher or more raw sample from the source, whether that's the well or the city water line that is distributing water to your home. So there's a whole spectrum of options in between first draw and fully fleshed samples. Make sure you pay attention to which kind of sample you want. You can talk to our support team anytime and ask questions about what the different samples imply. We have some great blog resources to go in much more detail about the differences between first draw and fully fleshed samples. But think of it this way: what do you care most about seeing in your results? Do you want to see that worst case scenario of heavy metals in your water from old plumbing? Well, then do a first draw. If you want to see the nature of the water quality source itself, whether the well water or city water from the distribution system, consider doing a fully flush draw and letting the water run for a while first. Remember, the water that goes into your container is the water that's going to get tested. So make sure you're putting the water into that container that you think best represents your problem or best represents the kind of water quality you're consuming on a daily basis. So you build a new well or you install a new water filtration system at the home, and you're super excited to see how well it's working, and you take a sample right away from that new system or that new filtration device that you've bought, and you send it in, thinking you're going to see the best drinking water quality ever. Unfortunately not. Unfortunately, you're going to want to give any new installation, whether that's the well itself, plumbing, or a new filtration system you've installed at the home or on the premises, you're going to want to give that system a couple of weeks to really settle in and to find equilibrium with the water before really pushing it and seeing what it can do. So you wait a couple weeks, then collect the sample, then send it in for lab testing. If you don't do this and you just collect the first sample that comes out of the pitcher you bought or the first sample that comes out of the well that you just built or dug into the ground in the backyard, unfortunately, there's just a lot of weird stuff that happens during that construction process, or weird kind of chemistry that takes place when you have a brand new filter or a brand new membrane. And you really want to see what happens once that brand new wears off, right? So your first samples, first draw right after installing something new, are not going to be representative of how this thing really functions over time. So you're much better off waiting week or two, let the equilibrium set in between the water and this new hardware, and then collect the sample. Then what you'll see is a more accurate portrayal of the effectiveness or not effectiveness of whatever you've just done, whether it's the new well or a new filtration system. If you have any questions about this, I know it can be a little complicated, and I know it can be sometimes feeling very urgent to collect a sample to see if something works. Reach out to our team. I'm more than happy to give you some advice on how and where and when to collect a sample if you've just installed something new. Before you even collect your sample, you want to look at your day ahead and figure out when you're going to bring that sample to FedEx, when you're going to drop that sample off at the laboratory. The reason this is so important is you do not want to collect your samples and have them sitting around waiting. You want to get those samples to the laboratory as quickly as possible, and for every different test kit, that's going to be a different amount of time. Some of these samples need to be rushed to the lab the same day, others can wait a couple days or a couple weeks. But to always be safest, to always make sure your sample is best represented by the time it gets to the laboratory, you want to get it there as quickly as possible. So read the instructions, plan ahead, and make sure to collect your samples on a Monday, Tuesday, Wednesday, or Thursday. Try to avoid holidays. Try to do what you can to avoid something like a big storm or a vacation. You really want to make sure that your samples are taking a pretty basic run-of-the-mill day trip to the laboratory. So if it's collected on a Monday or Tuesday or Wednesday, it's going to arrive 1 or 2 days later, and that's great. If you collect your sample on a Friday and you drop it off at the post office or FedEx at 5 p.m., it might not arrive till Tuesday or Wednesday. Now, that may not be the end of the world. Depends on the test kit you're sending in, but it's always best to minimize the amount of time between the sample being collected and the sample arriving at the laboratory. Choosing when to collect your sample is absolutely vital to making sure that your water quality report represents your actual water quality. I'll give you some examples here. So if you collect your water quality sample directly after bathing a pet or an infant in a small sink or in a bathtub, there's going to be an impact of the bacteria, of the soaps, of the other chemicals in that water on the sample collected, because it's going to potentially touch the faucet tip and get into your sample jar. Another common circumstance is testing your water first thing in the morning. If you collect a sample first thing in the morning and nobody has used that tap at all, you're getting what's called a first draw sample. It's going to be a sample that represents the often worst case scenario for things like lead and heavy metals that might be in the plumbing of your home. This is because overnight, the water was sitting and touching those pipes for hours on end. Now, if you run that tap for 30 minutes that morning because you are doing dishes or making breakfast, by the time you collect your sample 30, 45 minutes later, your water quality is no longer going to be a first draw sample. It's going to have been impacted by the activities you took at that tap. So before you collect any sample whatsoever, you want to think about what are you doing at that tap before you collect that sample and thinking about whether that might be impacting the sample itself. If you have any questions about this sort of thing, because it can get very nuanced, definitely refer to your instructions inside of your test kit, or else reach out to us and the support team will help you make the right decision about when to collect your sample. If you're collecting a water quality sample with the hope of capturing some kind of a volatile substance, something that might evaporate from the water, and this is common for testing that includes trihalomethanes and chlorine or VOCs from, let's say, nearby oil and gas concerns or industrial waste. If there are VOCs that are important to you in your sample, it is particularly important to collect your sample with water running slowly. If you blast open that faucet and fill up the bottle as quickly as possible, you're going to be exposing the sample, the water itself coming out of your tap, to a whole bunch of air, right? It's going to be mixing more air into that water, into the container. And what that's going to do is increase the opportunity for some of these gases to escape before they're tested at the laboratory. So when you're pulling a sample, and this is a good practice always, even if you're not particularly concerned about VOCs and volatile substances, always try to collect your sample on a very low flow. You want to reduce the mixing of the water that's coming from the tap and going into your bottle as much as possible. Many faucets have a little piece of metal at the tip called an aerator. Now, you can screw this on and off most of the time if it's there. And we almost always recommend screwing it off before collecting your sample. The reason is a little bit nuanced and complicated, but for many samples, the contents of the debris that are collected inside of that aerator, which usually has a little filter, can impact the water quality over time, and it's usually best to remove the impact of that aerator from your sample. So remove the aerator before you collect your sample. This is particularly important if you're concerned about coliform testing, because bacteria can live in that little filter of the aerator. Do you need to remove the aerator? Is it a huge impact to your sample? Probably not. But if you want to do the best practice, if you want to have the most representative sample of your drinking water quality over time, when you send it into the lab, I do recommend removing that aerator before collecting your sample. Again, if you fail to remove the aerator, or you forget, or you just don't want to, it might not mean anything at all. This is just about trying to reduce any possible ways in which the aerator might impact your water quality test results. PFAS testing is a big trend right now, and that's partly because PFAS have been found to be everywhere, from the blood of polar bears to the kitchen sink. When you're collecting a sample for testing for PFAS, it is very important to make sure there are not outside sources of contamination potentially contaminating your sample. What I mean is this: if you're looking for PFAS in your tap water sample and in only your tap water sample, you want to make sure that PFAS from your jacket or from some saran wrap or for some other object in the kitchen is not influencing the PFAS levels in the water that you're putting in the container to send into the laboratory. So if you're collecting a PFAS sample, if you want to really focus on the PFAS that is in your tap water, it is really important to have no other sources of potential PFAS contamination around. And this can be tricky because PFAS is kind of in everything, or at least it was, and it's getting a little bit better now. But I would still not trust really kind of any product that you would normally put on your skin, on your hair, any piece of clothing that is water resistant, I would get all of that out of your way, out of the way of the kitchen tap when you're collecting your sample from the kitchen tap for PFAS, because you really don't want those things to influence the reading of the laboratory equipment when they analyze your water sample. And it's particularly important, by the way, for PFAS and more so than a lot of other water quality contaminants, because PFAS are tested for and detected at extremely low levels, like thousands of times lower levels than most other contaminants. That means that really small contributions of contamination can come from your Gore-Tex jacket or from some other device in the kitchen or for some lotion that you have that has PFAS in it. Some very small amount can make a really big difference in your sample. So eliminate those sources of PFAS contamination so that the sample you're collecting from your tap is indeed a sample of your tap water and not a sample of your whole kitchen. I hope I'm not the first person to tell you this, but it is very important to wash your hands, and it is especially important to wash your hands and make sure they're clean before you're collecting a tap water sample. There is kind of heavy metals and there are bacteria. There are all sorts of things that can be on your fingers and under your fingernails. It's kind of gross. I'm not going to go into any details, but your hands are dirty. Don't touch your water sample with your dirty hands before sending it into the laboratory. Do your best to clean them first with soap thoroughly before collecting your sample. If there are latex gloves in your sampling kit because your testing requires that, then make sure you wash your hands before you put those latex gloves on. Latex gloves are not an excuse to use the dirtiest hands possible because you have gloves on. Always wash your hands thoroughly with soap before collecting your samples to make sure your sample is most representative of your actual water quality and not the dirt and gunk that's on your hands. A lot of water testing kits include testing for coliform bacteria and other microbiologicals. If you're testing for coliform bacteria, if you're testing for any microbiological contaminant, it is very important not only to use a sterile bottle, which will be provided in your kit, but to use a sterile environment. Do not touch the sample lid, the tip of the faucet with your hands, or with anything else that might cross-contaminate your sample before collecting that sample. If you have questions about the nuances of collecting a sample in a sterile way, definitely reach out to the team to ask those questions. You can also consult the instructions that are provided in your sampling kit. As a first order of business, as a rule of thumb, treat any kind of microbiological sample, coliform samples included, treat them as being as sterile as possible, which means keep your fingers off of things and try to make everything a clean and swift sampling experience so that nothing can cross-contaminate the water that you put into that sampling container before sending it to the lab. Many sampling containers in water testing include preservatives. These preservatives are typically there to maintain the integrity of your sample while it's been collected and sent to the laboratory. You do not want to remove or touch or play with these preservatives at all. If there's a preservative in your bottle, it's there for a reason. Keep it in there, fill up your sample according to the instructions, and don't take it out. Certainly don't touch it or eat it. It is in there to make sure that your water quality sample arrives at the laboratory in a healthy and predictable way. Some of the most common uses for these preservatives are to dechlorinate a sample. It's also very common to control the pH of a sample or to perform some kind of a reaction that will limit your sample's ability to change while it's in transit. So if you have questions specifically about preservatives, definitely reach out. But the best rule of thumb is just don't touch the preservatives. Certainly don't eat the preservatives. Just fill up the bottles according to the instructions and let the preservatives work their magic as your sample makes its trip from your home or your workplace to the laboratory. No matter how hard you try to be perfect, it is not uncommon to still make a mistake. We all make mistakes collecting water samples, and if you do find yourself making such a mistake and you don't know what to do next, I can tell you right here. Go onto our website, talk to the team on the live chat, or send us an email, and someone We'll get back to you very quickly and tell you exactly how best to remedy whatever problem has been created, or maybe it's not a problem at all. Either way, the team will guide you through any kind of mistake you think you've made and ensure that you're not sending in a sample that you'll regret later. So there you have it. Those are the most common mistakes people make when they're collecting a water quality sample. If you have any other questions at all, please leave them in the comments section below. We will be very happy to answer you quickly. Thanks again for watching, and stay tuned for more information about drinking water quality.